two modules. The first module relates to security and the second module relates to privacy. Okay. So in this thing, first I want to explain what is security and what is privacy. What are the differences between security and privacy? Security refers to protection against unauthorized access, as you all know. But whereas privacy is protecting personally identifiable information. Let us take our COVID. In this COVID, some people are getting positive, but we have to hide their names and their location, their address. So hiding those sensitive information is nothing but providing privacy. So that is the main difference between security and privacy. Security provides protection for all types of data information, including the ones that are stored electronically. Privacy, I already told, privacy is nothing but protecting sensitive information. Sensitive information. Here, security can be achieved without privacy, but privacy cannot be achieved without security. Okay, the next thing is security program focuses on all sorts of information assets that an organization collects. Okay, so the security will give a protection shield for the data collected in an organization or for a person data. Okay, privacy focuses on personal information such as name, address, SSN. So you can hide certain sensitive information which are required to be hidden. Okay, that is the thing. It implements security protocols to provide. So the security relates to confidentiality, integrity, and availability of information assets. But privacy relates to protecting personal data. So you all know these things, but I want to introduce what are the difference between security and privacy. So after that, in this class, so what are the major concerns? You are having two major concerns in our daily life, whatever the application is. One is security and the other is privacy. So in this session, we are going to discuss how to deal with these two things using blockchain. So in that, I am working on blockchain based ecosystem. This is the latest research work. This should be very much helpful to all of you. Please listen very carefully. I will go very slowly, very slowly. So the first concept I am going to deliver is building blockchain based crypto system. You all know about crypto system. What do you mean by a crypto system? You all know about encryption and decryption. Encryption and decryption is nothing but a lock, a lock. So we are storing your valuable things in a locker, in a locker. So that locker will have a lock, and that lock mechanism is same for any lock. But the important thing here is in every lock the mechanism is same, but we cannot open all the locks with single key. So the security is mainly based on key being used. Key being used. I think you got it. So you may have many efficient crypto systems like encryption algorithms or decryption algorithms like CES, MES, etc. But their reliability is based on key being used. That's why. That's why. If you want to work on security, it is better to work on key generation. The key is very important. Now you are all connected in a conference. This is nothing but a group communication. How it happens? Because 90 to 100 people connected, connected in a in this um, what is this in this web platform through a group conferencing. So no other person will come into this group. Only the person who are having that key only can enter into the enter into this. Because if you are having only password, then only you can enter into it. So to make a group communication secure, we have to generate a key securely in between the people. So in the first part, my main focus is on key agreement. Main focus is on key agreement. So in the key agreement, you can talk about in between two persons. In between two persons. That is done by Diffie-Hellman. That is a wonderful algorithm. I liked it very much because there is no substitute algorithm for Diffie-Hellman yet now, because there are various versions, various developments on Diffie-Hellman is going to be done, but there is no substitute for that type of wonderful logic. It has been done in 1974, so I liked it very much. So I am working on that. Okay, so uh, so now you are going to work on group key agreement and key agreement. Security, privacy, trust in group key agreement using blockchain smart contract centric computing. Okay, so actually you are having many crypto systems. Here you are having key agreement between two parties, key agreement between n parties. N parties means group key agreement. But now I am going to introduce blockchain technology in those group key agreements to solve the security, privacy, trust, to incorporate security, privacy, trust in those group key agreements. That is my aim. So in that, you all know about smart contracts. Smart contract will make disintermediation. There is no requirement of intermediaries. You all know about that. So now I am using smart contract as a crucial role, in a crucial role for for a group agreement, for a traditional group agreement. So that's I am going to deliver in the first part. Okay. So actually, in modern world, most of the wireless systems require resource constraints. You all know wireless systems like RFID tags, sensors, smart cards, small processors, PDAs, and smartphones. These are all having resource constraints. So the computation and is going to be very difficult with the resource constraint devices. You can multiply 1 crore into 1 crore in a computer, but you cannot in a calculator. So we have to deal with resource constraint devices like mobiles, RFID, sensors, and IoT devices. So these devices will play a major role in providing security for satellite communication, internet security, e-banking, e-commerce, Internet of Things application, and embedded systems. Okay, you are having traditional crypto systems, but they will work for devices with high computational resources. But you are going to deal with resource constraint network. Resource constraint network. That means there are very less computational power, less communication power, such as. So we have to. That is the most challenging thing. So implementing security for wireless communication system using these resource constraint devices is the most challenging problem you are going to get at. Okay, so we are dealing with key agreement, in which key agreement in between what resource constraint devices. So we are addressing not only key agreements, we have to deal these key agreements in resource constraint networks, and I am incorporating or I am integrating blockchain technology to address large wireless harassment. Because if three people are there, we can the computational computation to find a group key between three persons is less. But if you want to find a group key between 1,000 members, the computation should be more. If it is 1 lakh, it is beyond. So what happens is we have to resolve the problem for large wireless networks. That's why I am going to address these traditional group key agreements or key agreements using blockchain. Okay, so That so, and also in what wireless communication system. So in which you are having very less computational resources, very less computational resources. Okay. So many cryptographic algorithms were developed to accomplish their requirement for secure data communication in wireless systems. You all know. You all know. There are many efficient crypto systems. But what is the problem with that? Increased power consumption, communication, and computational complexity with increased processing time. With increased processing time. So these communication, computation are very difficult with resource constraint. So you are going to solve that in this way. Thus, an efficient crypto algorithm that overcome these limitations is in need of. So you are going to work on those in this session. Okay, fine. So you all know about DLP, discrete logarithm problem based protocol. I already spoke about DP-Hellman key agreement. What do you mean by DP-Hellman key agreement? DP-Hellman key agreement is a DLP based protocol. So what is DLP? So here, if you take the background for group key agreement, so if you want to work on something, you don't have to be compromised at anywhere. You must have clear basic fundamentals on that. So before going to work on a group key agreement, first you have to know what is a group. Okay, you all know what is a group. Group means it is having some properties like clausal property, clausal property, Quasar property, associative, inverse identity. You all know about this. So I don't want to go into that because time doesn't permit me to go into that. But I will explain. There are two types of groups. One is multiplicative group, other is additive group. In multiplicative group, if A and B are two elements, the operation between A and B is A into B. But if it is an additive group, it is A plus B. So you all know that the computational complexity of multiplication is higher than addition. You all know that. It is very clear. It is very clear. So, with dealing with this computational constrained network, if you deal with addition, it is going to be easier. So I will explain later why you are converting into. So this TLP based protocols deals with multiplicative groups. There you are having two operations. One is A into B and A power B. A power B. So if you take 2 into 3, 2 into 8 is multiplication. 2 power 8 is exponential. So in multiplicative group, for each generation, you are having these two operations. One is multiplication, 2 into 8, other is 2 power 8. But I am comparing this multiplicative group with additive group. In additive group, 2 plus 8, 2 plus 8. And other operation is, here it is exponentiation, 2 power 8. Here it is 2 into 8. Okay, is it clear? Is it clear? So here in multiplicative group, you are having 2 into 8, 2 power 8. In additive group, 2 plus 8, 2 into 8. This 2 into 8 is called as scalar multiplication. Here you are having exponentiation, there you are having scalar multiplication. So if you can use these additive group, then computational load will be down. So and you can adapt these additive groups to what? What? That is constrained network. So you can reduce complexity like that. I will explain that very, very clearly. Very, very clearly. Okay. So first what is introduced? DLP based protocols are introduced. The first symmetric group key agreement or public key group key agreement is DP-Hellman. That was invented in 1974. So most of the group key agreement protocols are DLP based because it is the base. It is the base. However, the key length for secure DLP DH has increased over the recent years because it is multiplicative group. There are multiplication and exponentiation. The computational processing load is high on applications. That is the problem with DLP. Okay, so DLP is nothing but DH. DLP is nothing but DH, making them not suitable for ad hoc networks and ad hoc networks and also resource constrained networks. Okay, ad hoc network means it may not be static; it will be moving towards. So ad hoc network, it won't work for this. So due to limited bandwidth, slower CPU speed, and limited battery power, so on wireless links, it is going to be difficult. Okay, so you need another alternative for this. Another alternative for this DLP based protocol. Okay, is it clear? DLP based protocol. So now the main base of our today's session is DP-Hellman, because whatever the symmetric key agreement you are going to establish between two party means two person, or among three or more persons, the base should be DP-Hellman only. So we have to learn DP-Hellman very clearly. Okay. So before going to start DP-Hellman, first we have to take a finite field. Finite field is nothing but 1, 2, 3, p minus 1. P is a prime number. So don't confuse. I will explain it very easily. So first, here there are two people. One is Alice and Bob. So Alice will take small x, Bob will take small y, and G is called group generator, and that will be that will be taken before the key agreement by the two people are agreed on some group generator G, because G may be public, that may be known to anybody, no problem with that. G may be known to anybody. So first what Alice will do is Alice will take small x private, means what it means, so that is known to only Alice only. Small y private to Bob, small y known to Bob only. So first Alice computes public key. Public key is G power x mod p. G power x mod p. So that is public key of what? Alice. And he will send that public key through public channel. So anybody can know G power x. So anybody can know G power x. G also known to anybody because it is a public. They will agreed on that G and P prime number on publicly. They will agree. So no problem with that. So G power x mod P is sent to Bob, and Bob compute its public key G power y mod P, and that is sent to Li. So after getting G power y, you can see here G power y, x is known to whom? Only Li. So G power y whole power x will be computed by Li. So what he'll get? G power xy mod p, because G power yx is same as G power xy. G power xy mod p is generated at Li. And similarly, Li send G power x to Bob, and y is available with Bob. So G power x whole power y. So Bob gets G power xy. So now what happens? G power xy is generated at Li and generated at Bob. Both are same or not? Both are same. So we can use that as shared key. That as shared key or symmetric key. So why? Because these two people will know this key. Yes or no? Surely. And nobody cannot compute this key with the information available publicly. What is the information available publicly? G power x, G power y. G power x is sent to Bob, so anybody can pick that G power x, and Bob sends G power y, anybody can pick that G power y. With G power x and G power y, we can compute G power x into G power y, that is equal to G power x plus y. That is not G power xy. That is not G power xy. So That is the security with DP element. So this property is